understand acidification, we need to understand CO2. CO2 is a combination between one carbon and two oxygen atoms. It comes out of pretty much everything we do, be it driving a car, setting up a factory, and industrial fumes, or just a simple act of breathing. Now, let's talk about the properties of CO2. First of all, it's non-conservative, which means that it dissolves in water extremely quickly and has a short residence time, as opposed to nitrogen, which is a very conservative element. Lastly, CO2 is very soluble and tends to combine very quickly. It is 1,000 times more soluble than oxygen or iron. As a result, you have lots of CO2 coming in and a bit of CO2 going out. What's more important though is that CO2 chemically combines with H2O to form H2CO3, a carbonic acid, which can dissolve into HCO3, the bicarbonate ion, or CO3, the carbonate ion. Keep in mind that reactions between these carbon compounds function on a two-way street in what is known as a bicarbonate buffer system. But to understand the system, you have to understand pH, which represents the density of free hydrogen ions in a solution. In a basic solution with a high pH, you see very few H ions, while an acidic solution is very concentrated in these ions. But how is pH related to carbon compounds? Basically, in a low pH environment, H2CO3 dissolves, releasing free H pluses into the oceans. However, in a high pH environment, the chemical process moves in the reverse, and H pluses are reabsorbed into carbon compounds. The result of this back and forth exchange between carbon compounds is called the bicarbonate buffer system, in which the moderator carbon compound, bicarbonate, dissolves and recombines constantly, ensuring that pH levels in the ocean remain at about an 8.1, with no lethal changes in acidity or basicity. Unfortunately, this system does have its limits, and we are testing them. By polluting the atmosphere with carbon dioxide from industrial projects, overbreeding animals, using CO2-intensive vehicles, and cutting down carbon dioxide-consuming rainforests, we are all injecting mass amounts of CO2 into the atmosphere, more than the oceans can bear. By injecting mass amounts of CO2 into the oceans, humans have created a dangerous shift in ocean pHs, with ocean pHs dropping by 0.1 in the last 100 years due to such human activity. We see that such acidification has had deadly impacts on the marine environment, as tiny organisms have to compete against growing hordes of H+ ions for carbonate, have weaker shells due to corrosive effects of acid, and are forced to expend precious energy to expel hydrogen ions out of their bodies. The end result? Death. And ocean acidification is a perpetuating process. After the original CO2 injection acidifies the ocean, the resulting changes in pH kill off many of the tiny phytoplankton that filter CO2 around the ocean by either photosynthesis or by just driving it down into the deeper ocean. And when these organisms die, carbon dioxide doesn't circulate and hence builds up, resulting in a chain reaction of more acidification. The end result? The destruction of the entire marine environment. If we wish to hold on to all the benefits that ocean life provides us, like boundless supplies of oxygen from phytoplankton, tasty fish, and incredible diversity of life to explore, then we must reduce carbon emissions, lest our oceans become graveyards.